Our topic today is cutting toolpaths with the YAS CNC Router. In the previous video we took a line drawing and used VCarve Pro to convert the JPEG image into a set of vectors. Let's add one more vector as a cutout path. For this vector we choose the rectangle option from Create Vectors. We keep the anchor point centered and create a square vector 200 mm by 200 mm. We confirm that all vectors are properly centered and switch to the Toolpath tab. The material we've chosen for this job is a scrap piece of 12 mm plywood. The purpose of the square vector is so we can cut out the finished job from the plywood. The simulation in VCarve Pro clearly shows the end result. All that is left in the cutout are the small tabs that hold the job in place. Once the toolpaths are finished and checked, they are saved and transferred to the computer that controls the CNC router. The G-code toolpaths are loaded into the Mach 3 software that we use here at YAS Engineering. First, we position the router V-bit to the XY position we chose when we set up the toolpaths. For this example, bottom left. In the Mach 3 software, we set both X and Y to 0. To set the vertical or Z axis, we use a special 16 mm block designed for the purpose. A special function in the software slowly lowers the head to detect the 0 position for the Z axis. The Mach 3 software is programmed to allow for the 16 mm block, so in effect the 0 Z axis is now set precisely to the surface of the plywood. As a point of interest, you can see that G-code is a long string of numbers meant for the computerized CNC controller. This gives meaning to CNC, computerized numerical control. All is in order so the engraving can begin. When we use an engraving toolpath, the depth of cut made by the V-bit is controlled by two parallel vectors, such as we have in this example. If the two vectors are close together, the depth of the cut is shallow. The further apart the vectors, the deeper the cut. As much as I like watching the CNC router do its job, for this task it soon becomes painfully obvious that the machine is running way too slow. Before the job is finished, I throw in the towel and start again, with a much faster feed rate for the router. Also, I decided to make the job about 25% smaller, just to see what effect it would have on the depth of cut with this set of vectors. Back in VCarve, we use the Edit button for the tool and change the feed rate from 1000 to 4000 mm per minute and the plunge rate from 200 to 2000 mm per minute. All vectors must be recalculated and saved again before starting the new job. Now we're all much happier with the faster feed rate and plunge rate, and there's no reduction in quality.
I've taken it off a JPEG file and let VCarve set the profiles, and I haven't touched the profiles at all.
Yeah, it's quite happy going fast. We've had it to 9,000. I was making a pocket and it couldn't have the other one.
That makes a difference, doesn't it?
Yeah. I couldn't stand waiting that long.
For this job I decided to run a bevel around the cutout path while the V-bit was installed. For this cut, the centre point of the V-bit is positioned to cut right on top of the cutout vector. We are now ready for the final cutout, and this requires a change in the cutter bit. For the cutout path we use a 3mm bit with a flat tip, cutting to a depth of 12mm, which is the thickness of the plywood used for the job. On the final pass we can see that the router is adjusting for the tabs that hold the job in place during the final cut. With the light behind the job we can easily see the tabs. I hope you've found this overview helpful. Vectric software is a powerful design tool. Paired with a quality machine such as the YAS CNC Router, there's a whole new world of creativity to be enjoyed, for pleasure or for profit.